Hi guys, welcome to this lesson where we explore the use of logarithms and the antiderivative. Now as you can see from this little formula we've got to use, we're going to get logarithmic answers when you've got an x on the bottom of a fraction. Now we're going to say, does it work for just x being there and just a number 1 on top? Well, luckily we've got this other idea. Now it's a bit more complicated, but it's got a function on the bottom of our fraction, and it will turn into this logarithmic function provided that we get the derivative of that function on top of that fraction. Now you may say yourself, well, how many times will that actually happen? Well, sometimes we're just going to have to manipulate things to make it happen. Okay, so example 1, and we've got that set up. We've got the x on the bottom of that fraction. Okay, so when you're doing a question like this, maybe this can now scream out to you, hey, can I get an answer as a logarithm? Okay, so when we go and apply this basic rule, we're sort of saying, what have I got different to this setup here? And that's that number 3 sitting on top. All right, so when we go to integrate this, all we're going to say is I've got 3 lots of that base e logarithm plus c. All right, so if there's a number 5 or a number 17 on top, it'd be 17 lots of that base e logarithm plus c. Okay, with example number 2, we're going back to finding areas enclosed. Between this hyperbola, y over equals 1 over x, and the x-axis and these lines x equals 1 and x equals 2. And then we've got to make sure we're giving the answer as an exact value. So what do we think that exact value might mean? Yeah, it means not putting it into our calculator and leaving our answer in log form. Okay, so maybe you might have to apply some log laws or any other of those other special features associated with logarithms. Okay, as per normal with these area questions, it's a really good idea to just draw a quick sketch. So this hyperbola, all right, so it's our basic hyperbola sitting in quadrants 1 and 3, and we're looking at it enclosing it between the lines x equals 1 and x equals 2 and the x-axis. So we are looking for this little area here. Okay, so we're asked to find areas, which means we're going to integrate. Now it's between 2 and 1. It's all positive in that top quadrant, so we're not having to worry about any negatives or breaking it up into sections. And we're going to integrate 1 over x with respect to x. Okay, that x on the bottom screams out to us that maybe we can use a logarithm. All right, so that's going to give us log base e of x. All right, remember, no need for the plus c this time because we're finding that actual area, not having to worry about that constant. Okay, substituting. Now this is where I said sometimes you might have to use some log laws to simplify. So if we're taking away, that really means we're dividing. So it's log of base e of 2 over 1, which is log of 2 base e. And we're talking about an area, so that's units squared. Okay, in example number 3, it's got a bit more complex. We've got something a bit larger than just x on the bottom. We've got x cubed plus 7, which means we're going to have to maybe lean on that second version of these special formulas. Okay, so let's just go revisit it. It says if you've got a function on the bottom and you have the derivative of that function on the top, then it will produce this result. Okay, so now we're going back to that idea of linking, differentiating, and the antiderivative, going forwards or back, up or down, however we want to think of it. All right, so when we get this sort of question, the thing we really got to focus on at the start is that bottom of the fraction. Now what you really got to be thinking is, what's the derivative of that bottom part of the fraction? Now in this case, the derivative is 3x squared, and then that 7 is being absorbed. So now I'd be thinking about going back to my original question. And this is the way that I like to talk myself through a question, is I'd be saying, for this big idea to work and for me to use logarithms, that top part of that fraction has got to be this, 3x squared. Because the derivative of the bottom, for this case is 3x squared. So what I'm going to do, maybe even with a different colour pen, I'm going to go and manipulate that top half of the fraction. And in this case, I'm going to put my 3 at the front because my x squared's already there. Now what I've essentially done is multiply this fraction by 3. So to keep that fraction equivalent, what I should do now is also divide that fraction by 3. And the way we do that is we come out the front here and we multiply it by 1/3. Because multiplying by a third is the same as dividing by 3. Alright, so by doing that, this new statement that I've made, it gives me a big tick for that formula. So I know what that's going to be worth. When I integrate that, it's going to give me log of base e of that function, x cubed plus 7 plus c. However, I've still got my 1/3 to deal with. So all I do is I say I've got 1/3 of that logarithmic function. So this little bit of manipulation over here, thinking in that way, allows me to go and use that new idea. Okay, question 4. And again, on the bottom of this fraction here, we've got something pretty messy. It's definitely not going to be using that first little idea. It's going to be the second one, where I've got to consider that function and its derivative. Okay, so I'd like to come over here and say, here's my f of x. It's x squared plus 2x plus 4 this time, which means my first derivative is 2x plus 2. So what this is saying is, up here on top, I want that to be 2x plus 2. Because if that top line was 2x plus 2, then I could go straight to this idea and have a really easy question. Right, but very rarely will it really work first time for you like that. So we're going to have to manipulate. Okay, so here's what I'm asking myself. How do I get this x plus 1 and how do I turn it into 2x plus 2? Generally just by multiplying or dividing. And yeah, if you can see, we've got, if we put a common factor of 2 at the front, or multiply that top line by 2, I can turn x plus 1 into 2x plus 2 quite easily. Because I've chosen to multiply that top of that fraction by 2 to make it balance, I've now got to also divide it by 2. So hopefully you can see some sort of pattern emerging here in the process you've got to take to do some of these harder questions. So now just to perform our integration, so we're going to get log base e of x squared plus 2x plus 4 plus c, but we're only going to have half of it. Alright, and that's it. I hope you enjoyed these lessons and good luck with your homework practice questions. Remember to feed through those questions you have for your teachers on Google Classroom.